Hello and welcome to the Code and Designing YouTube channel. In today's tutorial, we will discuss about DBSCAN clustering algorithm and machine learning in data science. And after reading some theory insights, then we will do some practical work of DBSCAN and Jupyter Notebook. So first of all, let's read some slides. Cluster analysis is an unsupervised learning method that separates the data point into several specific bunches or groups, such that the data points in the same group have similar properties and data points in different groups have different properties in some sense. It comprises of many different methods based on different distance measures, for example, k-means, affinity propagation, mean shift, DBSCAN as we are discussing here, Gaussian mixtures, and spectral clusterings. Centrally, all clustering methods use the same approach, that is, first we calculate similarities and then we use it to cluster the data point into groups or batches. Here we will focus on the density-based spatial clustering of application with DBSCAN clustering method. Why do we need a density-based clustering algorithm like DBSCAN when we already have k-mean clustering algorithm? K-mean clustering makes cluster loosely related observations together. Every observation becomes a part of some cluster eventually, even if the observations are scattered far away in the vector space. Since cluster depends on the mean value of cluster elements, each data point plays a role in forming the clusters. A slight change in data point might affect the clustering outcome. This problem is greatly reduced in DBSCAN. Due to the way clusters are formed, this is usually not a big problem unless we come across some odd-shaped data. Another challenge with K-mean is that you need to specify the number of clusters in order to use it. Much of the time, we want know what a reasonable k-value is parity. What is nice about DBSCAN is that you don't have to specify the number of clusters to use it. All you need is a function to calculate the distance between values and some guidance for what amount of distance is considered kilos. DBSCAN also produces more reasonable results than k-means across a variety of different distributions. As you can see in the figure, in DBSCAN good way as compared to k-means. Density-based cluster refers to one supervised learning method that identifies distinctive groups clusters in the data based on the idea data cluster in data space continuous region of high point density separated from other such clusters by continuous regions of low point density. Density-based spatial clustering of application with DBSCAN is a basic algorithm for density-based clustering. It can discover clusters of different shapes and sizes from a large amount of data which is containing noise and outliers. The DBSCAN algorithm uses two parameters. Number one is minimum PTS and number two is epochs. The minimum number of points a spatial cluster together for the general to be considered dense. A distant measure that is used to locate a point in the neighborhood of any point in epochs. These parameters can be understood if we explore two concepts called density reachability and density connectivity. Let's discuss about reachability. In terms of density, establish a point or reachable from another if it lies within a particular distance epoch from it. Connectivity, on the other hand, involves a transitivity-based chaining approach to determine whether points are located in a particular cluster. For example, P and Q point could be connected if P is greater than R is greater than S to carry Q, where A and is greater than B means B is in the neighborhood here. There are three types of points after the DBSCAN cluster is complete, cold, border, and noise. Now discuss about practical lab of DBSCAN. First of all, we will upload some library here. As you know, we will import library by using import. Then we make a function here.